All right, study on research designs. So, first question. What do you think? The more highly educated a woman is, the fewer children she is likely to have, true or false? And the less time students spend on Facebook, the better their grades are. Either of these statements may be true. We want to know if we can prove them to be true. We will begin with experimental research. So experimental research. We would ask questions such as the one listed up there, does highlighting improve retention of information? What about questions like, can pills make you smarter? Is the newest trend in exercise, say CrossFit, more effective than other types of exercise? Is a certain therapy effective or more effective than another in treating patients? Those are all questions that we would want to have a definitive answer. Yes, pills make you smarter, or no, pills do not make you smarter. If you're spending an hour in the gym, you want to know, yes, I'm most effectively spending my time. So how would we know? How will we know that CrossFit is more effective than distance running, right? If we're going to spend an hour, right? No. Okay, so how do we know? Are we guessing? What kind of research will we do? So going back to that, does highlighting improve retention of information? A simple experiment. You would have an instructor randomly draw names so that everybody in the room had a 50-50% chance of being put in either group. So two groups, one is going to highlight, one is going to not highlight. Random assignment, the two very important things, random assignment, everyone has the same chance of being placed in either group. So what about random sampling? Quick little bunny trail quickly. Random sampling or representative sampling. So would this study be representative of the general population or college students if we used fourth graders? You want to be very careful in the samples that you use. Okay. Question number 1. Why is it important to do research rather than to rely on intuition alone? Simply because sometimes our intuition is wrong. We discussed earlier that we are usually 80% certain that our answers are correct. When we use our intuition, common sense, and we are only actually correct about 40% of the time. So often our intuition is simply wrong. Discussion, what is the independent variable in the example? Does highlighting improve retention of information? The independent variable is the highlighting itself because it is what is being manipulated in the experiment. What is the dependent variable? The dependent variable is retention of the material. One easy way to remember what the independent and dependent variable is in an experiment is that the dependent variable depends on the independent variable. So the dependent variable depends on the independent variable. We manipulate the independent variable. Lastly, importance of random assignment. We just discussed this quickly before. But why was it important to randomly draw names to assign students to the highlighting condition? If I did a study where I gave you all $20 and I wanted half to spend it on themselves and the other half to spend it on others, who would volunteer to be in the first group to spend it on yourself? This lets us know the importance of random assignment. We can't volunteer ourselves to be in one group or another. We don't want to self-select into groups. we would then run into the chance of the groups being fundamentally different. So using my example from earlier, also, if we are trying to figure out if highlighting improves retention for undergrads, but we're using fourth graders, we would have two very fundamentally different groups. If groups were fundamentally different, and that means in things such as age, gender, race, education levels, there are almost any variable can skew your results. This would be a confounding variable. It would confound your results. They would not be generalizable. You would not be able to use them. Random assignment is also important because it helps ensure even sample sizes. So if you were allowed to self-select, I'm going to bet if I had 30 of you that probably 25 of you would self-select into the group that gets to spend $25 on yourself. All right. Experimental research. This, I'm actually going to place the link onto Brightspace and post the questions for the online students. All right, correlational designs. So remember, in experimental research, we can prove that one thing causes another. Correlation, what does correlation mean? That one variable predicts the other. Correlation does not equal causation. That means we cannot definitively say that one causes the other. Correlation points us toward predictions, but they are imperfect ones. An example, children who were abused are more likely to abuse their own children, but that does not mean that most abused children become abusive. It means that they may be more likely to, but not that they're going to. Okay, so Facebook. Does Facebook cause depression? Does depression cause more time on Facebook? A confounding variable may be that the person has no friends, and so therefore they do spend more time on Facebook and they are more depressed. We do not know the direction of causation. All we do know is that in this example, there is a relationship between depression and Facebook usage. Right. We have positive and negative correlations. So some examples. The more children use various media, the less happy they were with their lives. That is a negative correlation. The more they used media, the less happy they were with their lives. The longer children were breastfed, the greater their later academic achievement. So both of those, they were breastfed longer. Their academic achievement was greater. That is a positive correlation. Another one, the more income rose among a sample of poor families, the fewer psychiatric problems their children experienced. So the more income rose, one variable increases, fewer psychiatric problems, another variable decreases. That is a negative correlation. How do we talk about the strength of a particular correlation? The relationships we were just talking about are represented with a single number, the correlation coefficient. The correlation coefficient measures the strength and the direction of a linear relationship. So a direct relationship between two variables. It is designated with the lowercase letter r. So right here, r equals 0.75. That is a strong correlation. Correlation values range from a minimum of 0, which is zero correlation, no correlation whatsoever, to a maximum of 1.0. R values can be positive or negative. A negative 1.0 is an equally strong correlation as a positive 1.0. Remember, the negative and positive just indicate the direction of the variables. Okay, so if we were to look at these relationships, time on social media and exam scores, animal lover and owning a cat, and having a sweet tooth and number of desserts consumed. Time on social media and exam scores likely represents a moderate negative correlation. R equals negative 0.50. As one goes up, time on social media, the other, exam scores, will go down. Animal lovers and owning a cat likely represents a weak positive correlation. People who are animal lovers are more likely to own an animal. It does not necessarily mean it's a cat. Having a sweet tooth and the number of desserts consumed is likely a strong positive correlation. If you have a sweet tooth, you're just more likely to eat more sugar. Correlational designs. These graphs represent two of the studies discussed earlier. They show correlation. Which correlation, top box, bottom box, is stronger? Why would you say it is stronger? The top graph is the stronger. It displays a stronger correlation because of the steeper trend line. The bottom graph has a more gradual trend line, a more gradual negative trend line. Which correlation is positive? The top. Top graph has a positive correlation because its values on the x-axis increase, values on the y-axis also increase. Bottom is negative because its values on the x-axis increase, values on the y-axis decrease. Which graph represents R equals negative 0.21? Which graph represents R equals 0.90? The bottom graph represents an R value of negative 0.21, which is indicative of a weak negative correlation. The top graph represents the R value of 0.90, which represents a strong positive correlation. The bottom graph is a close representation of the highlighting study we discussed. There was not a significant relationship between highlighting and retention for undergrad students. Interestingly enough, there is a much stronger correlation for highlighting and graduate students. Okay, why can't a researcher say beliefs about caffeine cause greater alertness? This was in a video that we watched. The answer is the same though. Correlational designs look at only the relationship between two variables and not which variable causes a change in the other. Correlation does not equal causation because a third variable may be acting on the correlation between beliefs about caffeine and ratings of alertness, or on our earlier example, Facebook and depression.